Hello, welcome back, my jelly beans. How are you today? I hope you're well. So, what I was thinking about doing in this video was looking at map work skills. I want to check out different types of scales. So, how we measure distance on a map using different scales. We'll see how it goes. Okay, so let's get through to the theory first. Here we go. So the first thing that I want us to look at are the different types of scales. So scales is how we would measure distance on a map. We have three main types of scales that we look at. Make sure this is up and running. There we go. So we have three main different types of scales that we look at: word, line, and ratio scales. A word scale is the simplest to work with, although we don't really use it very often in map work. A word scale is basically where you are expressing a scale in words. Let's first consider what is a scale. So a map is obviously a smaller version of the real thing. That makes sense. I mean, the earth is quite big. We can't fit it onto a piece of paper without making it smaller. The scale tells us how much smaller it is from the real thing. So we can see that if we measure something on the map, if we measure a centimeter, it usually has a certain distance that it's representing. So if I measure a centimeter, in real life, that centimeter is actually 500 meters. Okay, so the scale tells us how much bigger the real distance is from the map. And it's important that we use the word represent because it's not a case of 1 centimeter is 50 kilometers. They're not the same thing. A centimeter is not the same as a kilometer, but the centimeter is symbolizing a kilometer. So I just want to make sure that the students don't get confused with saying that a centimeter is 50 kilometers because they're not the same thing. It's just demonstrating it. So I have these two examples over here. 1 centimeter on the map represents 50 kilometers on the ground. So it's a way of saying the scale. 1 centimeter represents 10 kilometers. So this is a shorter version. I usually use the second one when I'm actually talking, but the full scale would be 1 centimeter on the map represents 10 kilometers on the ground. Hello, welcome back. Line scales. Line scales we are probably a bit more familiar with. So a line scale will be a physical scale that's on the bottom of the map and it shows us little intervals. Now, do not make the mistake in thinking that each interval is a centimeter. A lot of the students that come to me, they are under the impression that if there is this interval, like from there to there or there to there, it's definitely a centimeter because that's how it should be. It's not always a centimeter. You get different types of maps, and different types of maps will have different scales. So you must measure it first. Okay, we'll take a look at one. So line scales have these little intervals, and each interval will have a set distance that it's representing. So let's go back to the previous one. 1 centimeter represents 50 kilometers. So it might have an interval like from there to there that is a centimeter, and on that scale, it will then have a little 50 or something like that over there. Let's see if we can draw an example. So let's take this word scale over here, where it has 1 centimeter on the map represents 50 kilometers on the ground. I want to make a line scale of that word scale. Okay, first of all, let's draw a line. Now, I don't have a ruler that I can use on the actual computer. Okay, that looks like it kind of works. It's more or less the same interval. And we're going to say that that interval, we measured it. Now, we measured it, and we measured that this was 1 Oh dear, sorry. 1 centimeter. Good. So each one of these little intervals from there to there measures 1 centimeter. 1 centimeter. Good. Happy so far? Okay. And I said that 1 centimeter will represent 50 kilometers. So where we start is 0. Then at the first 1 centimeter interval, it's 50. It made it into a circle. Okay. 50 kilometers. 100 kilometers. I don't know why it's turning it into circles, but okay, that's fine. I can't just figure out these letters and, neaten up my handwriting. And 150. There we go. Okay, so far, that's fine. We can make that out. We're happy with it. Yeah? Now, I want to show you what I mean by the intervals don't always have to be 1 centimeter. So I'm going to redraw this line scale, but as a 2 centimeter intervals. But the actual scale, I'm going to leave the same. You'll see what I mean now. I think I prefer this whiteboard. Don't think it's giving the same issue so far. So previously, I was saying that 1 centimeter represented 50 kilometers. Weird handwriting. 50 kilometers. Um, my future self is going to tell me that I've written this incorrectly. And hopefully when we get there, you'll be able to explain to me why I wrote this incorrectly. But it's fine as it is for now, for the purpose of this exercise. I want to make these intervals 2 centimeter intervals. Okay, it's okay. Okay, now it's 2 centimeters. So each interval is 2 centimeters that we measured, and I want the actual scale to still be the same. So I still want 1 centimeter to represent 50 kilometers. So what that means is, oops, so if this ratio is still going to be the same, then that means 2 centimeters, oh dear, is representing 100 kilometers. Okay, with me so far. So on both sides, I just multiplied by 2. And that means that up here, that is now 100. So 2 centimeters interval represents 100 kilometers, just like 1 centimeter represents 50 kilometers. And this would be 200. Great. Oh, right, and the starting point here. This is 0. Okay, but we don't have to show these units throughout the whole scale. So a scale it won't have this, it won't have these, that you would have to measure, and it doesn't have to have the kilometers on each one. It can just have it right at the end, and that means that each one of these intervals is 100 kilometers. Then 1 centimeter represents 10 kilometers. Let's try something similar. So if I'm sticking with these intervals are 2 centimeters. Sorry, it's not a very good job, but it's fine. So that each one of those intervals is now 1 centimeter. So this is 2 centimeter gap, and this is a 1 centimeter gap. And what was it representing? 10 kilometers. 30, 40, the weirdest 5 in 50 ever, kilometers. Okay, I think that's okay so far. So we've looked at what word scales are, and we've looked at how we can represent them as line scales as well. Okay, the next one is a ratio scale. This is one of those ones that the students either love it because it's so easy to work with or hate it because there's a lot of maths involved. But a ratio scale is where one unit on the map represents a certain number of units in real life. So I want you to notice in the previous ones, we had centimeters to kilometers, or even over here, we've got some mystery value to miles. So this probably, I don't know, centimeters to kilometers, maybe this is inches to miles, I'm not sure. We had some unit comparing to another unit. In this case, there are no units. There is a reason for that. It's not a unit representing another unit. You can think of it as it's a magnification. So in other words, if I have a map that is 1 to 1,000, it means that whatever I measure on the map is actually 1,000 times bigger in real life. So if I measure 1 centimeter on the map, it's actually 1,000 centimeters in real life. If I measured 1 meter on the map, like I somehow have a 1 meter map, if I measured 1 meter on the map, it is representing 1,000 meters on the ground. Okay, the reason why I think this can be very simple to work with is that all you have to do is multiply it by this number. Whatever you've measured, you multiply it by this number. Now we're going to do some practice questions. We're going to take a look at a very common map that we use, and we're going to see if we can try and measure some distances using this map. The golden rule of ratios is that the units are always the same. I say to my kids, I do not care what you're measuring with, as long as you know that your answer is that units. This map is a topographical map. Okay, what I want to point out is that we have two different types of scales that are being represented on this map. First, I want to point out down here, but that says 1 to 50,000. That is a very important ratio because all of these topographical maps will always be 1 to 50,000. If they had been printed to scale, if they're a correct map, they are 1 to 50,000. This is one of the maps that my students need to be most familiar with. This is the map that we start working with as early as possible. Then look next to that over here. Okay, do you see there where I've highlighted? I've highlighted the line scale. You can see that it starts at 1. Don't worry about that one. We just worry from 0 for now. That little starting from 1 to 0 can be very useful when you know how to use it, but I don't actually have the tools to show you how we measure that. It's one of those little pointers. Wait, there it is. Oh wait, is this a transparent one? Is this a transparent image? It is. It is awesome. Okay, I can possibly show you how we use this. Maybe. I'll see. Okay, but this is what I was referring to, these pointers. So if you've ever used one of these in school, you'll know that you can make it wider and narrower, and that's what we can use to measure distance. So I'm going to see if I can find 2 points, because I obviously can't actually change the size of this image. But I'm going to see if I can find 2 points that can fit within this pointer so that I can show you how we use them. Don't know if this is working. If you can't already tell, I'm trying to make it the size of the race course so we can measure the length of the race course. That's what I'm trying to do over here. Okay, don't let my difficulties dissuade you from using this method. It works a lot easier when you have the physical instrument. So I think that's close enough. That looks like it's on either side of the race course. So what I'm going to do now is I'm going to, virtually pick it up off of the map, and I'm going to take it to the scale. It's fighting me. I can't seem to get it onto that 0 point. But the idea is that you should be able to see that, okay, it's not really, there's the end of the point. It's not quite 1 kilometer. It's just short of 1 kilometer. So then what I would do is I would take that point and take it back to the nearest whole kilometer, which in this case is actually 0 because it didn't get to the whole 1. Let's take it back to 0. Okay, now you might notice that the right-hand side is on the 0 and the left-hand side isn't quite on the 1. So I want you to count how many little blocks are between the 0 and the 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what that means is that 0 to 1 is broken up into 10 intervals. So it's a 1 kilometer stretch broken up into 10. That means that each one of those little blocks is 100 meters. And if we count now, what is the distance between the 0, so the one pointer to the other pointer? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 little blocks between the 2 pointers. That means that that race course that we measured is 900 meters long, well, lengthwise. So that is what these things can be used for. They can be very helpful, especially if the distance that you're measuring is smaller than the actual scale. If it's not, if it's longer than the scale, we need to use the ruler. Okay, so before I started, I was spending time painstakingly resizing this ruler to make sure it was the right size for this map. The reason why is because each one of these intervals, those 0 to 1 and 1 to 2 intervals, we know that that's 1 kilometer. Each interval is 1 kilometer. But if we actually measure it, you will see that the distance between those two numbers is 2 centimeters. So I want to pick up the ruler and show you that, prove to you that it's 2 centimeters. And then I want us to use the ratio scale and then show you how we can get from 1 to 50,000 to 1 to half a kilometer. Okay, that's not perfect, but I think it's close enough. So you can see over here, when I put the ruler onto this line graph, each interval should be 2 centimeters. This is what I do every time that I print maps for my exams. The people at the printing company already know. I have to have a ruler with me as soon as they print the map. I grab the ruler, I measure the scale on one of the printed maps, and I make sure that that little block is 2 centimeters. Then I know that the whole map has been printed to scale. Then I know that it's 1 to 50,000. Okay, now I'm going to show you how did we get from 1 to 50,000 to 2 centimeters per kilometer. So we're going to convert these two scales a little bit. For now, you just have to make do with my really bad handwriting on the whiteboard. Okay, so our ratio was 1 to 50,000. And now saying, now how do I get this to 2 centimeters represents 1 kilometer? Well, which one should I do? Should I do 2 centimeters to 1 kilometer, or should I do 1 centimeter to half a kilometer? I suppose it comes out to the same thing. Let's do the 1 centimeter to half a kilometer. So remember, it doesn't matter what I measure with, as long as it's consistent. So because I want to express it as 1 centimeter to half a kilometer or 500 meters, I need to start by measuring in centimeters. So what that means is that my ratio is expressed as 1 centimeter. Here we go. 1 centimeter to 50,000 centimeters. Now, the question is, do I want this in meters or do I want it in kilometers? So my actual distance. Either way, I'll convert to meters first. Then I'll convert to kilometers. So if I said that I want to want this as so many centimeters represent so many meters, to go from centimeters to meters, I need to divide by 100. There we go. Divide by 100, and then I will get meters. Now I'm just doing this side. This is all that I want converted to meters. So this stays a centimeter. So now this is 1 centimeter. If we are dividing by 100, I know that the maths teachers out there would hate me for this. We're just gonna cancel out the zeros. I know they hate it when people say that, but we're not doing maths, we're doing map work. So we're gonna cancel out the zeros. I'm sorry, maths teachers out there. Please forgive me. Okay, because 100 has 2 zeros in it, we're gonna cancel out 2 zeros. And what is left is 500. Yay, 500 meters. Now, what do we do if we want to get this into kilometers? I know you guys, you're smart. You would tell me that we need to pick a different color first, tangerine, and then divide by 1,000. Okay, so we divide by 1,000. Now you're gonna see that we actually don't have enough zeros to cancel out, so we're just gonna put a little mythical comma over there. There we go. Let's just move that comma up. So we have 1, 2, 3 zeros. So we're moving this up 3 places. 1, 2, 3. So our comma moves to there. And that means that now 1 centimeter represents 0,5 kilometers. Okay, now I know that if you're in the older grade, this was really easy, but please bear in mind that we do scales from, I'm going to say from grade 8 because that's when I start with scales, but I know that we start with scales much earlier. So I wanted to make sure that we have a step-by-step of this from the beginning. Now we see how we got 1 centimeter represents a half a kilometer. And if you think about that line scale we measured, it was 2 centimeter interval. So we can still do the same thing. We can say times both sides by 2. We're not converting in this case. So it's not like when we had the units and we're just doing it to one side. Okay, so if we're timesing both sides by 2, because it's a ratio, there we go. That means that 2 centimeters represents 1 kilometer. Good. Now let's do a few little practice runs. So I was going to use the actual map for this. I was going to use the ruler and like measure on the map and find 2 points. I'm trying to paste the map into here, but I might just end up reusing this little math extract in one of my actual lessons. Hey, that worked. Yay! So I'm going to let's find a random point. Let's make this a bit bigger. We have this 1217 over here. Do you guys see that? So that is a spot height. And maybe we can go to, that looks like a reservoir over there. That little blue block. Yeah, I think let's go from there. So the corner of that blue block over there to that spot height 1217. Oh, an important thing to note. When you're measuring with a ruler, you don't measure with the end of the ruler. So you can see this is the very end, that's the line over there, and here is the 0 line. You don't measure from the edge of the ruler. You measure from the 0 line. And I had a student in an exam a couple years back who was stressing because their ruler was broken. And what it basically meant is that it had broken off up to like the 1 centimeter line. So somewhere around here, it had broken and they thought that they couldn't measure. Like, of course you can still measure. You just measure from now the 2 line. So instead of counting from 0, you count from 2. So it's from the 2, you go 1, 2, 3, 4. So I think they probably just had a panic moment in the exam, like, my ruler's broken, I can't measure anything. You can measure, you just start measuring from the next solid line. You don't ever measure from the edge of the ruler, you measure from the 0. Okay, now we wanted to measure from the reservoir, the corner of the reservoir there. I think that counts. And we were going to, this is tricky. This is not as easy as I thought it would be. Okay, that's quite close. Yeah, that's good enough for me. I don't know if you guys can see that. I've told my students, I'll tell you guys again, you are allowed to bring a magnifying glass into the exam room. Don't feel bad sitting there with your exam paper and a magnifying glass. It's okay. It is actually in the exam instructions. Maybe just check with your teacher first. But I know in our exams, it's perfectly acceptable. Sometimes I happen to have a spare with me that the students come and ask for before the exam starts. So over here we can see that the 0 is in line with that corner. That's where I wanted to measure from. So that corner over there. And I know it's a little bit unclear, but the dot, it's a lot easier for me to see on my screen because my screen is quite big. But the dot is going through right there where the cross of the cursor is. I can see it. Okay, so I'm gonna count. So we've got 1, 2, 3, 4, 5, 6, 7. The dot is not at the 7 yet, it's at the 6. This is 6.5. And you can see it's just 1 over the halfway mark. So it's 6.7, sorry, 6.6 centimeters between those two places. Yay, we have our first measurement. So I measured 6.6 centimeters. Good. Now I want to know, what is it in real life? We can use this scale that we had figured out earlier. So we can use that one. I'm going to use this one first, the 1 to 50,000. So I'm saying that we haven't converted it yet. Where I think that ratio scales can be quite easy is that the ratio is a magnification. So 1 centimeter on the map is 50,000 centimeters in real world. So that means that everything is 50,000 times bigger. So I'm going to rephrase that whilst I write this out. Everything is 50,000 times bigger. 50,000 times bigger. See what I did there? Yeah. Okay, I'm not putting units in. I don't care about units at this point. I only care about units when we get to the answer. So all we're going to do is we're going to take that 6.6 and we are going to times it by 50,000. Now, please excuse me whilst I grab my calculator. Okay, 330,000. My units. Whatever I measure in, that is what my answer is in. So I measured in centimeters. My answer is in centimeters. Now, at this point, I would go back to my question. If I'm doing a test or an exercise, I'd go back to my question and I would see, how did the question want it? Did it want it in meters? Did it want it in kilometers? And then I would convert it. Because we don't have a question, we're going to convert to each one. So we have our answer in centimeters already. That's great. Then I'm first going to convert it to meters and then to kilometers. So centimeters to meters divided by 100. And no, I don't need the calculator for this one. I can do this one. We're going to cross out the zeros. 1, 2 zeros because there's 2 zeros there. Okay, that's 3,300 meters. And then finally, I'm going to express the same thing in kilometers. There we go. By 1,000. 3,3 kilometers. Yay, we are so clever. Okay, so the distance between those 2 points was 3.3 kilometers. What units you choose to convert to can depend on the question. So if finding the distance is all you had to do, like this, like if you just had to find the distance between the 2 points and the question said convert to kilometers or convert to meters or whatever else, then that's 100%. Sometimes a question is lining you up for another question. So let's say you are doing a section on gradients and in gradients, you prefer to have your units the same. Then you would look at what units am I measuring height in? And I'm going to convert my distance to those same units. But then by the time you get to that, you would be so used to this already. So what units you do the distance measurements in can be influenced by what you are busy with. If you're just finding a distance, it's whatever the question says. If it's just a part of a bigger question, then look in context of the bigger question. Okay, I think we're pretty much running out of time. I wanted to do a little bit of, wait, let me just see, have I gotten through? So we did everything that I wanted to with the scales and distances. I've showed you how we measure it. I showed you how we convert the different units. I really hope that this has been helpful. Are there any questions on this? I hope that this is all making sense, and I hope that you've learned something new. But thank you very much for joining, and hopefully the section of map scales and distance is a little bit less intimidating now that we've seen how it can be used. Otherwise, I hope you have a lovely afternoon, and then I'll see you again next week. Thank you for joining. Cheers. Bye.